In the previous lesson, we talked about how to use the compound interest formula and the compound interest formula continuously. And in this lesson, we're going to extend that and talk about how to solve exponential equations. So, first we need to understand something called the one-to-one property. The one-to-one property tells us that if two exponential functions have the same base, then their exponents are equal. So what does that really mean? Well, looking at example 3 here, 2 raised to the power of 3x plus 4 equals 4 raised to the power of x minus 1. Right now, we have no way of solving this equation besides using guess and check. But this one-to-one property tells us if I could write these two equations with the same base, then I can set their exponents equal. So if I look at 2 and 4, I know 2 and 4 have a common base of 2. So I'm going to leave the first half of this equation okay, because they're already written in the common base. So 2 raised to the power of 3x plus 4 equals, I'm going to rewrite 4 with a base of 2. 2 squared x minus 1. Now since they have the same base, I can take their exponents and set them equal to each other. So 3x plus 4 equals 2 times x minus 1. And now it just becomes a simple equation to solve. So 3x plus 4 equals 2x minus 2, and now we use inverse operations. Subtract 2x, and subtract 4 from both sides. So x equals negative 6. If you wanted to, in the end, you can take x equal to negative 6 and put it back in the original equation to check if it's true. With example 4, 9 and 27 have a common base of 3. In this case, I have to rewrite both of these equations. So 9 is really 3 to the second power. 27 is 3 to the third power. So same base, exponents are equal. So I have 4x plus 2 equals 3 halves. Subtract 2 from both sides. I get 4x equals negative 1 half. And I divide both sides by 4 to get x equals negative 1/8. But what happens as soon as I have a fraction in my raised to an exponent? I can still find a like base. If I look at 5 and 25, they have a like base or common base of 5. But since this is a fraction, I need to start thinking about negative exponents. So if I rewrite this with a negative exponent, I can get it to be 5. So 5x to the raised to the x minus 6 equals 5 to the negative 2 power x minus 1. Again, same base, exponents are equal. So x minus 6 equals negative 2x plus 2. And now we use inverse operations. Plus 2x. 3x minus 6 equals 2. Add 6. 3x equals 8. And finally, x equals 8/3. So now again, looking at example 6, we know 1,000 and 100 have a common base of 10. So if they have a common base of 10, we can rewrite it. Well, again, fraction means I need to think about negative exponents. So 10 to the negative third power equals 10 squared times 2x minus 1. Again, same base. Exponents are equal. And now I solve. 15x minus 24 equals 4x minus 2. Subtract 4x. 11x minus 24 equals negative 2. Add 24. You get 11x equals 22. And finally, x equals 2. So now you know how to use interest formulas, and you know how to solve exponential equations.